Good morning, students. So today we're going to do a really quick follow-up lesson to what we've been learning about measuring liquids using a graduated cylinder or a beaker. Now, the unit that you use when you measure with these is usually milliliters, because in science class you're usually measuring small amounts of liquids. So we use the metric unit of milliliters. I have my graduated cylinder here, and this one has graduations of fives, right? So it goes up 5, 10, 15, 20, 25, 30, 35, 40. And the beaker goes up by 25s. So here you can see that it goes up by 25, 50, and then it doesn't actually say 25, but I know that the first marking is 50, and then there's one in the middle that doesn't have one, and then there's 100. So if it goes 50 blank 100, I have to think, okay, so there's 50 between the 50 and the 100, right? Because 50 plus 50 is 100. So this middle mark must be whatever is halfway between 50 and 100. And I know that that's 75. So I think to myself, well, it must be going up by 25s each marking. So when you're looking at a measuring tool for liquid, you always have to look carefully at what the number is on the beaker, because sometimes it could be 5s, sometimes it could be 25, sometimes it could be 100. So you just have to pay close attention to that. So today we're going to be learning about something called displacement. Now, there are times when we get an object, like this rock here. This rock is an irregular shaped object, meaning it's not going to be easy for me to tell how much space it takes up, because I can't just take out my ruler and measure the length and the width. It has all of these different bumps and all the sides are different. It's shaped irregular. So if I wanted to find out how much space this takes up, I would use displacement. So I'm going to take a little bit of food coloring and drop it into my measuring tools. And this will make it a little bit easier to see. I'm going to just stir it around a little bit, stir it around a little bit. Okay, so if I wanted to find out how much space this irregular shaped rock takes up, first I have to know how much liquid is in my measuring tool to begin with. And I have a little bit over 100, so I'm actually going to get another cup, and I'm just going to pour a little bit of it out so that it's right at the 100 mark. So to do that, I have to be very careful to measure it and then look back at it again. Make sure, remember from the video we watched, when you're using these kinds of measuring tools, you want to have your measuring tool sitting flat on the table, and then you move your body so that you can see if it's flat and see the meniscus. So now I see that it's starting at 100. So my starting measurement is 100. Now, if I want to find out how much space this irregular shaped rock takes up, all I have to do is drop it in here, and it's going to take up space because it has matter. It's going to take up space and make my water level go up. Now, did I put any more water in here? No. What happened? Well, the rock takes up space. So it pushes the water out of the way so that the water level moves up. Now, if I look at my measurement, see if I can zoom in for you. You see it? Zoom in a little bit. Well, now my water level is a little less than 125. So I have to estimate because I don't know what those little numbers are right between each of them. I just know that it's between 100 and 150, but there's the 125 mark, and it's a little below that. So I could say it might be 123 milliliters, right? So what I can do here is a little equation. So now I know that I started off with my water level at 100 milliliters. But now, after putting my rock inside of it, the water level rose to about 123 milliliters. So to find out how much space this rock takes up, all I have to do is find the difference between those two. So 123 minus 100, if I take 100 away, is just 23 milliliters, right? So this large irregular shaped rock is 23 milliliters. So on my paper here, if I was doing a worksheet, which you guys will be doing, I would write rock equals 23 milliliters, because that's how much the water level rose when I dropped it in, right? Let's do another example. So now, who knows who this little guy is? Yes, if you guessed Olaf, you're correct. So Olaf is irregular shaped. Let's see how close I am here. Oh, there's Olaf. Olaf is irregular shaped. He's got a little stick on his head. He's got his arms. So if I wanted to find out how much space Olaf takes up, he's small, I would go to my graduated cylinder. Okay, now, my graduated cylinder, if I look at it right on the side and look for the meniscus, it is at 25 milliliters. So, I'm starting off at 25 milliliters. Now, if I put Olaf in, I have to squeeze his hands together. To find out how much space he takes up, I'm going to dunk him in, and as you can see, the water level has risen. Now, it started at 25. Let's see if I can get a little bit closer with you guys so you guys can see it. Well, now it's at 26, 27. So, we started at 25. Start. We ended at 27 milliliters. So now, what is the difference here? 5, 6, 7. So, Olaf is equal to 2 milliliters. That's how much space Olaf is taking up. So, you guys are going to be doing a worksheet where you guys see a graduated cylinder, and then it has a starting measurement, just like the one that I showed you, that you have to measure what the starting measurement was, like I did. Then it shows you that there's a object inside of it. You're gonna look at the object and then measure how high the meniscus is after it's been dropped in. And then you have to do a little subtraction problem. So the subtraction problem should be whatever your final milliliters minus starting, because the starting will always be less, right, equals the volume of the irregular shaped object. Make sure that you always mark it with your unit, which is milliliters, okay? I'll give you some more feedback on that later. I hope this video was helpful. Stay well, everybody.